So in the last video, we talked about the phases of database design. And I just want to show this small picture where the conceptual model, you see here, the external model is when we're collecting information from the user. When we go to the conceptual model, you see that we have these boxes with some arrows, but the boxes are kind of empty. And then we go on to the next step, which is the logical model design, or we call it the internal model. And you see that we are starting to add more information. And then when we go to the physical model, you see that the boxes are starting to get more filled in. So as you go from one model to the next, what you're basically doing is adding more details. Okay, so when we say high level of abstraction, it means we do not have a lot of details. We just have an overview, a general overview of how things are going to look. And then as we go down, we're going to go to a low level of abstraction where things are no longer abstract. We don't have abstraction. We don't have a high level of abstraction. We have a low level of abstraction. We know exactly how everything looks. So we're going to start with the external model, and the external model just represents the user's view of the database. What information do they want you to store? And if you talk about what needs to be stored, and you talk to different people, they are going to tell you different things. So if you talk to me at MCC about what needs to be stored, I will tell you I need to see a list of all the programs that are at MCC and the required courses. I need to see a list of students with their transcripts and GPA and test scores. If you talk to the registrar office, they will have a different view. If you talk to HR, they will request like bank information about all the employees, the employee mailing addresses, social security number, W-4, W-2, like all that information. So if you talk to maintenance, they will say, well, we want to know all the rooms. We want to know the location of all the bathrooms and the location of all the boilers and AC units. So everyone you talk to will have a different list of information that they want you to be storing for them. So when we're talking about the external model, we are not talking about just one person's user view. We are talking about many people's external views. And so you might have to talk to different people in different departments to collect all the pieces of information that you really need to put in the database. And so here, as we said, an instructor might want to see the student's name, email address, and banner ID, but human resources wants to see the student's name, bank account, and how much they're getting paid in an hour. And the registrar wants to see what courses a student is enrolled in so they know how much tuition to charge. And the bursar's office wants to see how much each course is going to cost, what financial aid is going to provide, and the remaining balance. Every office, every department is concerned with different information. Every department has their own personal view. They have their different external views. So when we're talking about the external model, we are collecting all these different external views so we can see the big picture of how everything is going to fit in. Okay. So at that point, we have an idea of all the information that we want to store. We are ready to move on to the next step, which is the conceptual data model. Now, conceptual data model, we are starting to think in terms of what are we going to store in the database. So the external view, we are collecting information. Now we are starting to gather all this information and say, okay, what is it that we need to store information about? And so we want to represent the data in a way that is close to how the humans perceive the data. Again, we're not really thinking about how it's going to be stored in the database, even though it's really hard as a programmer or a computer scientist to not think about that. You know, you always think, you know, we are used to thinking, and what's the end result going to look like? So I know immediately you're going to think, oh, I need to create these tables. Right now, with the examples that we're going to be giving in this class, that is okay. That might be possible, but I'm just going to tell you that in real life, you cannot go to what am I going to put in the database immediately from just talking with people and looking at the external models and the external view. So I want you to just put that in your mind, that you need to kind of refrain from immediately going and starting to type your tables, and which is the physical model, which is the last step. So here in the conceptual model, after you talk to all these different people, you're going to ask yourself, what are the real world objects that I need to represent? So when I talk to people at MCC, you know, people talked about students and faculty and courses and programs and rooms. Each one of these real world objects is going to be represented by an entity. So we say that a student is an entity, a course is an entity, a room is an entity. If you talk about a doctor's appointment, a doctor appointment, or an event that's happening is an entity. So you have an entity, a real world object that you are going to be storing information about. When you start thinking about what information am I going to store about a student, or what information do I need to store about a room, we are now talking about attributes. So we start breaking up all the information that the people have provided us into real world objects that I need to be representing and saving information about in my database. We call those entities. And each of these entities, we want to see what information we're going to store about each one. So if I say a student, I need to store the student's name and social security number and address and email address and banner ID. If I start thinking about a course, I need to store the course name and course number and professor. A room, what am I going to store about them? So these are called attributes, what I'm going to be storing about these entities. The next thing that we want to also think about in the high-level conceptual data model step is the relationships between these entities. So when I want to see the relationship between a student and a course, I know that a student can be enrolled in multiple courses. I know that a course can be have multiple students. So this is called a many-to-many relationship. And we're going to talk more about what kinds of relationships exist. But for now, we need to know what real-world objects we're going to represent. Each of these real-world objects, what are the attributes that I'm going to be storing? What are the things that I'm going to be storing about this entity, basically these attributes, and the relationships between these entities. And so when you list all of these pieces of information, you will have your conceptual data model. Now, sometimes they tell you that the attributes come later. So this is different depending on which book you look at. So some books say that the attributes come, you decide on the attributes in the conceptual data model. Some books say that the attributes come later in the next data model that we're going to talk about, the logical data model. So I just want to tell you that there is a small discrepancy between where people say that the attributes come. But in general, we'll just keep them at the conceptual data model for now. And what's very important to keep in mind is that process of creating this conceptual model is independent from the implementation. So when you are coming up with your conceptual data model, you don't really care at that point what database you're going to be using. Are you going to be using Oracle or Postgres? It doesn't matter. So we want to always make sure that whatever we're doing at the high level steps does not depend on a specific database. Okay, so it's just, we're just doing high level at this point. And it's also independent of the hardware the database will run on. So because we're going to see different database models in future videos. So at this point, we're just concerned about how we're going to model the data to represent in some database. What database it's going to be on, what hardware it's going to be on, all that doesn't matter at this point.